Hello, what's up guys, it's Tekosor and today we are going to do something pretty interesting. So I have a Ryzen 9950X3D for quite some time now, along with this awesome board by Gigabyte, which is X870E AORUS X870E AI top. It's in fact the highest end board for AM5 socket. It has 18 plus 2 plus 2 VRM design for power phases. So it's going to ensure that you are not going to have stability issues while overclocking your CPU. And like it has Gen 5 support for PCIe, and it also support for the top M.2 SSD. It support Gen 5 speed, so that's nice. And it has great support for DDR5. It has like all the features that you would need, and it's very high end. Still, it's way cheaper than like the competition, like MSI Godlike or ASUS Extreme board. So this one comes a little bit cheaper and it serves pretty well. So anyway, we are going to do in this video some tuning in BIOS for this board by using AMD PBO, and we are going to check curve shaper and check out the potential out of this board and this combination with this CPU. So if you have a different board, it's not really a problem. You can just try to copy the settings that I'm going to use and just like enjoy this video as an informative way to check out benchmarks. And we are going to do a lot of them and also some gaming, like before tuning with PBO and after tuning with PBO. And we are going to do lots of stability tests, like to make sure that it's fully stable with all our new settings. I would like to say that the BIOS I'm using is F4, which has been released in March 13, 2025. So if you have a later BIOS, it's even better. If you have a previous one, I would suggest that you update it. Like it has some fixes. You can see it has fix for AMD CPU microcode signature verification. It has enhanced PCIe compatibility, optimized memory compatibility, and like you can see all the latest patches by AMD. So it's also going to improve gaming performance for two CCD Ryzen CPUs such as the 9950X3D. So please make sure that you have this BIOS, or a later one would be even better. So as of making this video, this one's the latest one. Okay, so as soon as you go to BIOS, you can see it launches in this easy mode. Like you can see those easy settings on the fly. I like this dashboard. It's very simple and gets the job done. Now here you can see there is this option called build for X3D. There is this X3D turbo mode by AORUS. So they made this easy settings that you can use to boost your X3D CPU. However, I didn't use it yet. So in the future, I may use it and like make a comparison between our new settings, our manual settings versus this X3D turbo mode. So maybe in the future, stay tuned for this kind of comparison. So press on advanced mode in order to go to our uh, advanced dashboard, so we can control more settings. Here I have for CPU clock control, it's set as auto. Like nothing has been changed in this part. CPU ratio mode to all cores, CPU clock ratio to auto, active OC tuner. You can see in the description, it says change dynamically between PBO and manual OC settings. To get maximum performance, the users need to manually set a preferred CPU clock ratio value. So here you can customize between PBO and manual OC settings. Now I have it currently disabled because I didn't study it enough. So maybe in the future, I'm also going to study it. And if I find it to be useful or how to use it, I will make a video dedicated for it. But for now, I just keep it disabled. So I also have GFX clock frequency to auto. So this will mean the iGPU. There is this option called Precision Boost Overdrive PBO enhancement. So right now I have it also disabled. You can see when you click it, there are like levels like 90 level 1, 90 level 2, 90 level 3, 90 level 4, etc. Those mean temperature like 90 degrees. I'm also going to experiment with them and make dedicated video for those awesome features. So far, I didn't touch anything of them. There's also eco mode. I have it disabled, and also this X turbo mode that we saw it in the easy dashboard earlier. Here you can also activate it the same. So what I will do is going to advanced CPU settings to do our manual tweaks. So first of all, I usually disable virtual machine because I don't really need it, and it would like maybe improve performance a bit on Ryzen CPUs. So therefore, if you're not going to do any kind of virtual machine setups or work, it's better to disable SVM. Nothing has been changed to the PPC adjustment. It's P state 0. And I also disable global C state. So global C state would reduce thermals and power consumption during the idle modes, like it will put the CPU under a lower power state in Windows when it's not being used intensively. However, sometimes it will just reboot by itself when being in idle. Like it wouldn't be stable in lower power states if you keep global C state control enabled and have tuned like the curve optimizer or curve shaper. I encountered these issues quite some time, like in previous Ryzen CPUs, and it always gave me better stability when I kept global C state as disabled, and it also improved performance in some scenario in gaming. So I'd rather keep it disabled. So now I'm going to go to Precision Boost Overdrive, and here I'll show you what I've done. So Precision Boost Overdrive set to advanced. When you open it, you can see there is auto, disable, enabled, and advanced. And after you put it on advanced, I set PBO limits to motherboard. It allows the processor to run according to the increased PBT, EDC, and TDC limits defined by your motherboard. So it will be better to use the ones defined by your motherboard. Usually for this high-end one, it would be like unlimited. So there isn't really an issue if you put it on either motherboard or you set your own limits. It's not going to be an issue. If you put it on custom or manual and your board, for example, doesn't have a high power phase counts or VRM quality might be lower. So you could overstress it easily and cause it to have high temperatures, etc. So it would thermally be uncontrolled and it wouldn't be stable as well. So it will be better to keep it on your motherboard defined limits. Next I do is setting Precision Boost Overdrive Scaler to 10x. So this one will override AMD default silicon health management to potentially achieve higher sustained frequency under CPU load. So let's say, for example, you render a video or like rendering a scene in 3D or like doing AI stuff, not sure. By having this option as 10x, it will achieve higher sustained frequency under CPU load over time. So I usually keep it on 10x. You can experiment with other ones like let's say 4x, 5x. So it's essentially a better way to keep higher sustained clocks over time. So I usually keep it on 10x, and I had it like an option for all my previous Ryzen CPUs like the 9950X, 7950X3D, 7950X, and 5950X. Like I had it for all my Ryzen CPUs and they all lived well. Set max CPU boost clock override by plus 200 megahertz. So it would like increase the CPU frequency that may automatically achieve by precision boost to algorithm. So it's the highest limit. You can see you can increase it by 25, 50, 75, 100, 125, 150, 175, and finally 200. So I usually keep it to 200. It's useful to have CPU boost clock overdrive by plus 200. I usually just keep it to like this and it doesn't cause any stability issues in my case. You can also control thermal throttle as well. So I keep it to auto, but you can, if you want, you can set it to manual and change it. Like maybe you just don't want maybe to have a higher temperature, like you would set it to 70, 65, etc. And CPU won't go beyond this. However, it wouldn't also boost frequencies to higher limits. Like it will adjust frequency based on your set thermal throttle limit. So I usually keep it to auto. GFX curve will be the iGPU curve. Like for this integrated GPU, you can adjust its own curve optimizer for higher frequency per voltage. So I usually keep it to disabled as I don't use the GFX. In curve optimizer, this one is the traditional curve optimizer that we all know and like. You can adjust it just like usual, like all cores per core and also per CCD. So it's going to shift voltage per frequency. You can, if you set it to positive, it's going to set higher voltage, while if you go with lower voltage, negative values, it's going to boost to higher clocks per voltage. So we are like shifting the curve of voltage per frequency. Now finally, we have the curve shaper, which is a new addition in 9000 series CPU for Ryzen. So curve shaper is what I have been using for also 9950X, and I quite liked it, like it was simple to set up. And I'm also going to use it with a 9950X3D. So Curve Shaper is a new version of Curve Optimizer. It has been improved to some way, and also, in my opinion, it's easier to use. So it's going to change voltage across all cores and temperature regions. This can be used to more precisely tune the voltage required by your system. In general, low temperature corresponds to idle temps, mid temperature corresponds to 1T gaming workloads, and high temperature is for stress tests. Additionally, main and low frequencies are idle background tasks. Medium is high core count workloads, and high and max frequency are for gaming and 1T workloads. So we have main frequency, low frequency, mid frequency, high frequency, and max frequency. And each of them has low temperature, mid temperature, and high temperature. So this way you can shape the curve depending on frequency. Let me show you what I've said. So you can, of course, by default, it comes, all of them comes as auto, and I'm just going to enable it for mid frequency, low temperature. And you can see we have the sign. So between negative or positive, I'm going to set it to negative. This way we are shifting the curve in a negative way, so it can boost to higher clocks with the same voltage or even lower, like not really going to reduce temperatures. In fact, it's going to increase temperatures. However, it's going to boost to higher clocks at the same voltage. A nice addition, nice boosting method by AMD, and you can change the magnitude by up to 30. So you can see if I set it, for example, to 35, like it's going to say invalid input range. So 30 is the maximum value. I've set for all of main frequency, low temperature, mid temperature, and high temperature as negative 30. For me, it has been stable at low frequency as well. So for low frequency and mid frequency, I managed to keep it on negative 30. In mid also, it's the same story. I also managed to get it on mid frequency for all of low, mid, and high temperature as negative 30. Now here where things are going to get a little bit harder. So I've tested for quite a lot. I spent countless of hours testing and checking stability. For high frequency, I managed to keep it on negative 12, and for me it's stable this way. So I tested stability quite a lot. Like even if I set it to negative 13, it wouldn't be as stable as it should. So for me, negative 12 for high frequency works pretty well, as well as max frequency. So both high and max frequency works with negative 12 for low, mid, and high temperature points. So those are my tuned settings for Curve Shaper. So negative 30 for main, low, and mid frequencies in all their temperature points, and for high and max frequency, negative 12. So for me, this way it's going to be super stable. I tested stability for many hours, and for me like this it's good. I also made sure that I had global C state disabled, because you can see we have tuned for main and low frequency and mid as -30. So this way it wouldn't be stable if I keep global C state turned on. Sometimes it would reboot like when system is in idle. That's why I wanted to tell you that it's better idea to disable global C state, especially when you tune curve shaper or curve optimizer. So we are pretty much done with precision boost overdrive. There isn't anything else. We can just go back, and here I would like to show you some extra settings that I have. So I have expo profile for my RAM kits, which is G-Scale. You can see this model have very low timings like 26, 36, 36, 96 at 1.4 volt. So this kit is the latest from G-Scale, which has like the lowest memory timings for Ryzen with expo profile. I'm going to make dedicated videos for it to check if those timings are actually going to give you a performance uplift. I also have this XMP Expo high bandwidth support set as enabled. So this feature is made by Gigabyte. And what else? I wanted to go to vCore SOC, and here I've set it to 1.2 volt in order to prevent any kind of socket burning. I didn't hear of any issue with this board, especially if it's causing CPU burning. However, I usually got this habit to set vCore SOC to 1.2. This way it will be stable for Expo, and also in CPU and VRM settings, I've kept everything CPU vCore load line calibration to auto. This way it wouldn't interfere with my PBO settings. It just stables this way for me at default. I don't need to play with those settings for now. I just kept it the same. So finally, once you finish all, you can head on to the save and exit tab and save your profile, and finally save and exit setup. So for our first test, I have Cinebench 2024, the latest benchmark for Cinebench. I'm going to run it on multi-core and single core with PBO off versus on. All the settings we have set on PBO are on right, and without PBO on left. So you can see for the scores, it's not bad on either. Like on PBO off, we got for multi-core 2488, and for PBO on, we have 2538. So a very high score in my opinion. For single core, you can see it's higher on PBO off by 1 point. However, in multi-core, you can see the difference exactly 50 points. Now, let's check temperatures and some gathered metrics throughout this test. So you can see for CCD 0, which has a 3DV cache, you can see with PBO off, the maximum clock ratio that it has reached is 5,500 megahertz. While with PBO on, we have 5,640 megahertz. So you can see 140 megahertz increase in by having PBO on and curve shaper. While with CCD1, which is the non-3DV cache CCD, it managed to get to 5,725 megahertz with PBO off versus 5,795 megahertz. So also increase on this CCD, and all of that has contributed to the higher score we have seen. CPU max temp is 73 degrees Celsius with PBO off versus 84 degrees PBO on. So we have seen higher clocks, higher scores, and higher temperatures. So that's normal. We have like 11 degrees increase here, and CPU max power draw is 199 watt with PBO off, while it's 194 with PBO on. So it's about the same. So now here we have Cinebench R23 also running multi-core and single core test. So with PBO off versus on again, for results we got 43,137 point for multi-core with PBO off versus 44,598 with PBO on. 1,500 point increase when we have PBO on plus curve shaper. So 44,500 is like a top tier score. It's really, really high in my opinion. While for single core, we have 2,277 with PBO off versus 2,219 with PBO on. So with off, it's higher on single core, while on multi-core, it's higher on PBO on. It's not bad also with PBO off. Like, it's not really bad at all. 43,000, it's still awesome. But if you want higher score, higher performance for multi-core workloads, with PBO on, you are going to achieve highest potential out of this CPU. Let's check out temperatures and stuff here. For CCD 0, which is 3D cache CCD, our max clock ratio with PBO off has been 5,500 megahertz. So the same, while with PBO on, it's 5,660 megahertz. So you can see also here an increase by 160 megahertz. While with CCD1, it's 5,725 with PBO off versus 5,810. Also here an increase, a great increase on the non-3D cache CCD. For CPU max temp, we got 72 degrees Celsius with PBO off, while with PBO on, it has reached 95 degrees Celsius. So a great increase with performance and the clocks, but also with temperature. But that's normal, like 95 is the maximum limit set by default. So it's not going to thermal throttle here. It's at the limit. Like they defined it this way, when you turn on PBO, it will reach 95 degrees at some time. It depends on your cooling as well. I have like an AIO cooler, 360. With CPU max power draw, we have 199 watt with PBO off, so the same, versus 218 watt with PBO on. Now I would like to say that once you turn on curve shaper and PBO, it's very crucial that you run several stress test and benchmark. So here I have also OCCT running at extreme mode, which is the most intensive mode, and the load type is set to a variable, start cycle at 1. And like you can see here, we have different instruction sets. So it may be stable at one instruction set with our new settings and not be in other one. That's why it's crucial to stress test your CPU under different instruction sets. There are many tools to ensure that your system is super stable after your tuning. For me, OCCT is one of the best stability test tool. I highly recommend that you give it a run after setting your BIOS settings. So I would run it for 15 minutes. For me, 15 minutes is okay for now. So if it wasn't stable, it will show up immediately since those workloads are pretty intensive. So it will show up pretty soon. So running with PBO off versus on, you can see higher clock ratio. So before it was around 4,800 something 50. Now it's 4,983. So like 130 megahertz increase. Our curve shaper is doing its job. And you can see here with PBO off, our maximum temperature reached for CPU has been 78 degrees. Max package power is also 200 watt. And here you can see our clocks are at around, depends, like for some cores 4,900 something, for other it's 4,700, while with PBO on, our max temperature has been 95. So again, the same limit, it's not really an issue. So we have here a higher power consumption by almost like 30 watt. That's why our temperature has increased a bit. But on the good hand, you can see our max clock ratios is generally higher. So you can see 5,114, and for the lowest ones, it's 5,000. So 5,050 also. So there is an increase on clock ratios, and that's normal that it's going to consume more power and run hotter. And now we are going to do AVX 512. So before we did SSE workload, this time we are going to do AVX 512, which is a different workload. So it's crucial to make sure it's stable also on this one. So I've run both just to show you. You can see 1.06 volt with PBO off versus 1.01 volt with PBO on. So also here you can see with PBO on we have higher clock ratio. Now let's check out again here temperature, max temperature. You can see this time for PBO off has increased to 81 since AVX is more stressful workload than SSE. So it's going to run hot even with PBO off when you have an AVX workload running. AVX 512 is the most stressful kind of workloads for CPU. That's why it's 81, almost like 82 degrees. The same power consumption, 200 watt. And you can see the clock ratios, like none of them have 5000 and above clock frequency. So for some it's 4700, for highest ones like 4900. So they are not so high. Let's check now with PBO on. With PBO on, you can see again our max temperature is 95, which is the limit. That's totally fine. Package power 228 watt. So the same as before. Now let's check also here frequencies for cores. You can see 5114. The lowest ones is 5048. So the same as before, our clocks are at least 5000 and above for all cores. So that's nice. That's a welcome increase. And now I would like to point on to something very, very important for testing stability. So we tested stability so far by using OCCT. We've run SSE and AVX 512. And we also did Cinebench R23 and 2024. And it was totally stable, right? Yeah. Now I'm going to run IDA 64 stability test. You know, IDA 64 stability test is also free. Like you can do it in a trial mode. And here I have trace for CPU, FPU, and trace cache, and trace system memory. So all the default options that are enabled by default, nothing special. So for me, for curve shaper, it was stable when I've set for high and max curve points. When I set them to 13 and 14 and above, like for 14 it was stable on OCCT and Cinebench. However, with IDA 64, it's a different story. When I had them other than 12, which is the current one, you can see at the beginning it runs very, very well. Like I showed you this recording, so you can see temperature is 70, is around 70, not really that high. But like when it crossed 45 minutes, like 35 minutes of a stability test, it froze. System has frozen totally, not responsive anymore. So it was stable with -15 with Cinebench and OCCT. I had to set it to -12 for high and max frequency points. So after setting it to -12 for curve shaper, it's totally stable. You can see 2 hours, 14 minutes, and then I run it again, more 2 hours and 30 minutes. Like, so in total, almost 5 hours of stability test using IDA 64. And it was super stable with -12 for high and max in curve shaper. That's why I wanted to show you this, to encourage you to always like stress test in all those softwares. Like do your stress test in all of softwares available that you can have. This way you will ensure that your system is stable and you are just going to enjoy it this way, enjoy higher performance while being like safe, like not have this kind of worries that it's going to freeze or reboot or anything like this. With -12, it's super stable for me. After IDA 64 stress test, you can see our clocks have hit 5830 megahertz in some instance, while for other 5635 for the 3DB cache cores. It's lower than in the second CCD. You can see for temperature, it's usually not so high with IDA 64. I think IDA 64 is not the highest stressful test, but it's more like going between different power states. It's not the most stressful test. Like you can see, our power consumption is 168, so it's not really that high. However, it's a very good indicator to check stability, in my opinion. So how about in gaming? Here we are in Cyberpunk 2077 running at low settings 1080p using RTX 5090 in OC mode. You can see GPU is very overclocked. If we check FPS, it's pretty much the same. There isn't really a difference in FPS like between PBO off versus on. In gaming, I didn't experience like quite an uplift. You can see in the scores 308 average FPS for PBO off versus on. It's the same exact average FPS. Min FPS is also the same, and max FPS is pretty much the same. Our number of frames is also the same. And here we are in the Black Mist Wukong. Now here in this game, it showed a little bit of difference, a small uplift, let's say. Not really that high, guys. I just don't want you to get hype, but it gave me an increase of around 2 FPS. So here on average FPS, we got 294 before, and now with PBO on, it gave me 296. So 2 FPS increase isn't really going to change your life. For minimum FPS, 113 versus 118. So maybe it has improved our low FPS to some extent. So guys, that was it for this video. I really hope that you found it useful and you enjoyed your time. Please let me know in the comments below if you have any kind of question, like if you have an issue setting your CPU, even if you have a different port from a different brand, don't worry. I can try my best to help you. Also, feel free to share your benchmark scores, like maybe flex your scores. That will be welcomed as well. And if you have any issue as well, you can also reach out to me on Discord, TechOSword Discord server. If you have any question, I'd be glad to help out. And thanks for watching. And also, if you like this video, please give it a thumbs up and subscribe to the channel to TechOSword, as I'm preparing a lot of videos dedicated to this motherboard. You have seen we have lots of AORUS dedicated features. I'm going to test this 3D feature by them to compare our settings versus their settings to know which one is better for different scenarios. So stay tuned for this. And also I'm preparing an RTX 5090 OC tuning video. So stay tuned for more videos. And I really appreciate you guys. Thanks for watching and see you in the next one.